In 1963, scientists studying Hubbard Brook Experimental Forest in New Hampshire made a shocking discovery. Their most recent rainfall samples were nearly 100 times more acidic than usual. At these levels, additional downpours of acid rain would destroy the region's marine and arboreal ecosystems in a matter of decades. Urgently sharing their findings with fellow researchers, they were determined to answer two questions. What was causing this deadly rainfall, and what could be done to stop it? Rain is never just composed of water. Chemicals and particulates in the atmosphere can be found in every drop, and some compounds, like carbon dioxide, make even regular rainfall slightly acidic. But this pales in comparison to the powerful acids produced when water interacts with oxides of nitrogen, or sulfur dioxide. On the pH scale, which measures acidity, each whole number is 10 times more acidic than the one above it. And where normal rain has a pH of roughly 5.4, rain that's interacted with these gases can rank as low as 3.7. Oxides of nitrogen and sulfur dioxide can appear naturally as a short-lived byproduct of volcanic eruptions or lightning strikes. But power plants, refineries, and vehicles that use fossil fuels consistently pump large quantities into the air. These dangerous gases travel with the wind, spreading hundreds of kilometers from the pollution's source. Acting like roaming clouds of destruction, their presence dramatically increases the acidity of local precipitation, creating acid rain, acid snow, and acid fog. These all acidify lakes and streams, kill crops and forests, and damage soil to inhibit future growth. Over time, acid rain can even corrode human structures made of stone or metal. By the 1970s, scientists in North America and Europe classified acid rain as a major environmental threat. But despite clear evidence tying the problem to air pollution, companies denied responsibility and cast doubt on the research. In the United States, corporations lobbied against regulating pollution and convinced politicians that such policies would raise energy costs and threaten jobs. These obstacles led the government to delay changes and mandate further research into the issue. But after a decade of mounting concern, Congress finally took action. Since the bulk of sulfur dioxide emissions came from power plants, the government set a limit on the total amount of it the electric power sector could emit each year. Then, they divided the permitted emissions into a fixed number of allowances distributed to each power plant. A plant could then choose to emit as much sulfur dioxide as they were allowed, or reduce their emissions and sell their unused allowances to other power plants. This system, known as cap and trade, offered power plants the economic flexibility to keep costs low while strictly limiting pollution. Many critics called these allowances licenses to pollute, or said the government was selling clean air. But since the cap was set to lower 5 years into the program, it forced every utility company to reduce emissions in the long term. Some plants added desulfurizing scrubbers to their smokestacks, or switched to low-sulfur coal and natural gas. Oxides of nitrogen emissions were also reduced with relatively low-cost technologies. These advances allowed the power sector to grow while the cap kept pollution under control. By 1985, Canada and the European Union adopted their own solutions, and international treaties began circulating to reduce air pollution worldwide. Today, this science-driven economic policy has largely eliminated acid rain across the United States and Canada. And while many ecosystems still need time to recover, scientists have sped up the restoration of other areas by reintroducing essential organisms killed off by acid rain. Some countries like Russia, India, and China still rely heavily on high sulfur coal and continue to struggle with the environmental consequences. However, acid rain's relatively quick journey from major threat to minor issue is rightly celebrated as a victory for policies that protect the environment. Cap and trade can't solve every environmental problem, But by using scientific consensus to guide policy, adopting efficient technology, and being unafraid to impose reasonable costs for pollution, countries can stop a growing storm of destruction before it's too late.